to everyone. Good morning to everyone. It feels both pleasure and honor for me to host this program. Myself, Professor R.V. Kokotnoor, hosting the one-day state-level webinar on statistics for competitive exams, organized jointly under IQAC initiative by Department of Statistics and Department of Commerce of STC Arts, Commerce, BBA, BCA, and BSc College and PG and Research Center, Banhatti. I heartily welcome all of you for this webinar. Under this situation of pandemic, where there is a drastic increase in the competition of the students facing competitive exams, it's very essential to know the best strategy to crack these exams. So hence, in order to provide an opportunity to all those participants and the students who want to get to know about how to crack the competitive exams, this webinar has been conducted. And the prime motive of this webinar is to help all those students to know the tricks and techniques of cracking the competitive exams. I heartily welcome everyone for this webinar. Now, may I request Professor Geeta Sajan ma'am, uh, Head of Commerce Department of STC College, to kindly welcome all the dignitaries and participants to this webinar. Madam, over to you.
Sir, ಕೇಳಾಕತ್ತಿಲ್ರಿ? A very good morning to everyone. To present here with warm greetings, it gives me a great pleasure to extend a warm welcome on behalf of Department of Statistics and Commerce conducting a state level webinar on statistics in competitive exams. A systematic statistics in competitive exams by a resource person, Srimati Dr. B.Munoli, Professor, Department of Studies in Statistics, Karnataka University, Dharwad. So, on behalf of our department, I welcome you, madam.
Thank you.
I also welcome our beloved principals, today's president of this webinar, Dr. G.R. Junaikar sir. He has been motivating all the faculties of the college and support on behalf of our department. I welcome you, sir. And also, I welcome our beloved IQSC coordinator, Dr. M.N. Benur sir, for his continuous support. Otherwise, not possible to conduct webinar like this. Once again, I welcome you, Benur sir. And I also welcome the webinar organizing secretary, one who have support this webinar, Dr. P.R. Kengnal sir. I welcome you, sir. And I also welcome today's organizing secretary, R.V. Kokotnoor madam. I welcome you, sir. And I also welcome sub-coordinator of IQSC, Dr. Y.B. Kodru sir. I welcome you, sir. And I also welcome for the today's session all the semester students and research scholars and who have registered from the different places on this webinar. Thank you for the registration. We welcome you all participants of this webinar. Once again, welcome you all. And I also welcome all my colleagues for this today's section. So I welcome you all. Thank you.
Thank you, ma'am. Thank you for your warm welcoming. Now it's time to know that the introduction of this webinar. So may I request Honorable Principal of our STC College, Dr. G.R. Junaikar sir, to kindly introduce today's gathering. Sir, over to you.
चलो ನೋಡ್ರಿ started webinar B.Munoli and organizing secretary of this webinar Prakash Kingar sir, organizing coordinator Professor Geeta Sajjan madam, IQC coordinator Dr. Iman Benu sir, IQC sub coordinator Dr. YB Kodur sir, all dear delegates, all student friends and my colleagues. It's my pleasure and privilege to welcome all of you once again to this state level, one-day state level webinar on statistics for competitive examination. At the outset, I must appreciate the initiation taken by the Department of Commerce and the Statistics Department to conduct this one-day state level webinar on statistics for the competitive examination. Especially in a critical condition like COVID-19, it's rather difficult task to organize such a webinar. So somehow our colleagues have taken the initiation and conducting this one. I thank them also. In a global era, we need to empower our students with the global skills, and thereby we need to develop the global competency also. In order to enhance the global competency, our students must know the skills to crack the competitive examinations. In any competitive examinations, general knowledge, numerical abilities, reasoning abilities are badly needed. Similarly, for the proper analysis and interpretation of any problem, statistics knowledge is also needed. Hence, considering the importance of the statistics in a competitive examination, we have organized this webinar. Our resource person, Dr. B.Munoli, attended a number of seminar conferences and addressed thousands gatherings also. And I do believe that she got a rich knowledge in the same area. And I do hope that you will take the best advantage of the presence and the speech of a resource person. And once again, I requesting all of you take the advantage of this great deliberations in the same field. And I do hope that the webinar will succeed in the short span of time. Thank you very much.
Thank you, sir. Thank you for your warm welcoming. Now, may I request organizing secretary of this webinar and head of statistic department, Dr. Prakash Kengnar, sir, to kindly introduce today's eminent person, our guest. Please, sir, over to you.
Good morning to all of you. I am Dr. Prakash Kegra, Assistant Professor in Statistics, STC Arts and Commerce College, Banhatti, and Organizing Secretary of this webinar. I am very proud and happy today that Dr. B.Munoli Madam has agreed to speak in this webinar. It's a great pleasure for me to introduce our today's speaker and my teacher, Dr. B.Munoli Madam, Professor, Department of Statistics, Karnatak University, Dharwad. She has a brilliant academic record. Madam has done MSc, MPhil and PhD in statistics. She has successfully guided 3 PhD students and presently guiding 2 students. She has published 35 research papers in international and national journals. One article written in Kannada on reliability theory bagged Masti Venkatesh Iyengar Memorial Prize awarded by National Aerospace Laboratories in 2009. She has presented many research papers in national and international conferences and seminars. She has delivered 10 invited lectures in conferences and seminars, and also she has delivered 11 special lectures at other universities within India. She has worked as a chairperson of Department of Statistics, BOE chairman, BOS chairman, and member of many other academic bodies. She has also worked as a member examiner on BOS and BOE for various universities, and also she is a life member of many associations and societies. Thank you, ma'am. Thank you very much, ma'am. Now I hand over this session to today's speaker, Dr. B.Munoli, madam. Please, madam, start your session.
Yes.
Thank you, ma'am.
Thank you, Prakash, for a very nice, cordial introduction. and dear organizers, principal of the STC College Banhatti, staff members, participants, invitees, and my dear friends. Good morning all. At the outset, I thank the organizers for making me part of this webinar. I accepted to be part of this webinar for two reasons. One is Professor P.C. Mahalnobis, that is in his name. Today we are celebrating it as Statistics Day, Indian Statistics Day. The legendary statistician whose contributions to statistics and in development of statistics in India and the country India. Second reason is Dr. Prakash Kengnal. Prakash is our proud alumni, and any academic activity of our department students and to be part of that would be our pleasure. So I have accepted to be part of this. And now coming to the theme of this webinar, that is statistics for competitive exams. We like ours is traditional university. Of course, we teach theory, but as the time needs, that is the statistics for competitive exams, research in applied field. So every now and then society will be asking us what you are contributing to the development of the society. So we have to move towards, of course, our department is well known for theoretical studies, but still because of the need of the society and present era, we are slightly inclining towards applied part of statistics. And I hope I will do justification to this title or theme of the webinar, that is statistics for competitive exams. And it is such a vast topic, that statistics for competitive exams, we can have discussions for months together. That is, every aspect can be discussed hours together. Okay, but anyway, for everything there will be limitation. We shall restrict ourselves to the time and topic. Okay, and this. So I am concentrating mainly on that is, after getting the feedback from Prakash, that is more participants would be from commerce stream, that is BCom and MCom, that is students of the college. And the organizing department is also, one of the organizing department is commerce department. So I have, that is to an extent, presenting some problems related to commerce also. So I am considering the titles like measures of central tendency, dispersion, probability theory, and probability distributions. Of course, the topics on which most of the competitive exam questions would be testing of hypothesis, sampling theory, time series analysis, regression analysis, SQC and reliability theory, econometrics, and vital statistics. The various competitive exams that include statistics are UPSC, KPSC, RBI exams, KSRTC, staff selection, actuary, banking, and many more to the list can be added. Again, to justify the theme, let me start with some problems on the topics of central tendency, dispersion, probability theory, probability distributions, and then some problems in insurance or banking sector. Okay, so shall I start sharing the screen, Prakash?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah.
You must remember three things. Wear your mask properly, wash your hands frequently, and maintain a distance of 2 meters from others. And yes, do not forget to take your vaccine on your turn. For more information, call 1075 or visit www.mohfw.gov.in.
Prakash, shall we continue?
Yeah, ma'am.
Okay. Now,
Ma'am, screen share ಆಗಿಲ್ರಿ ma'am. ಒಂದೇ ನಿಮಿಷ ಆ್ಯಡ್ ಮಾಡಿ. ಓಕೆ ಆಯ್ತು ರೀ ಮ್ಯಾಮ್.
ಆಯ್ತಾ?
ಆಗಿದೆ ಮ್ಯಾಮ್. ಆಯ್ತು.
ಆಡಿಬಲ್ ಅದಲ್ಲ?
ಎಸ್ ಮ್ಯಾಮ್, ಇಟ್ ಇಸ್ ಆಡಿಬಲ್.
Okay. So the questions or the problems that I am considering initially from the low means with tougher level, from lower, that is toughness goes on increasing as we progress, and as and when we come across the problem while solving, what theory is required I will explain there itself as far as possible. So measure of central tendency is the number used to represent the center or middle of a set of data values. Usually we have 5 measures of central tendency: mean, median, mode, geometric mean, and harmonic mean. They have their own advantages and limitations, and they can be different measures of central tendency can be used in different scenarios. Okay. And a measure of dispersion is a statistic that tells you how dispersed or spread out the data values are. So with this brief definitions of central tendency and dispersion, we shall start looking at the problems. Okay. So as I told, first initially I have considered more simple problems, and then later we shall see. Okay. So at a grocery store, the number of per day sold processed fruit cans in 15 days, the data is given, and the question asked is outliers of this observation or of this data set. And look at the observations, most of them are around 50 to 70, around that. But there are just 1 and 2 observations which are too extreme. So the answer would be 50 and 150. That is extreme values. That is, you looking at those values, you feel that they do not belong to this group, that kind of observations. So outliers are extreme values, too small or too big values among data values. Okay. So the next problem is, when the data is arranged, the middle value in the set of observations is called as or is classified as. Among this, the median is the appropriate answer, because it is the definition of median is this. Okay. So next is, if the frequencies widely varies between different classes, means when the data is there and if we classify it according to some groups and corresponding frequencies are written, and if there is a disparity in the frequencies of the various classes, so in such cases weighted arithmetic mean is used. So this would be the answer. That is, based on the definition of weighted arithmetic mean, we can answer this question. The measure of central tendency, which represents over time multiplicative effects. Okay. So in business, finance, and banking sector and all, where we have multiplicative effects for inflation and compound interest, looking at the formula of the compound interest itself, you know the multiplicative effect on the amount that we receive after certain time period. So when we have this kind of data or problem, the appropriate measure of central tendency is geometric mean. Okay. So the definition, that is, if we have n observations, nth root of the product of the data values will be geometric mean. And in these cases, geometric mean should be used. Okay. So next problem is, the arithmetic mean is 12 and the number of observations are 20. Then the sum of all the values. So here the formula for the arithmetic mean is this, that is sum of all the values divided by the number of observations. So n into the arithmetic mean, number of observations or values into arithmetic mean would be sum of all the values. So 20 into 12, 240 would be the correct answer for this. The next question would be, if the mean of percentages, rates and ratios are to be calculated, then the appropriate central tendency to be used is weighted arithmetic mean. Okay. So again, basic definition. So here we have a problem. The product W has per unit contribution of 8 rupees with sold quantity of 124 units, and another product X has a contribution of 5 rupees and its sold quantity is 105. Similarly, Y the contribution is 9 rupees and the sold quantity is 135 units, and Z is its contribution is 12 rupees and 140 units is the sold quantity. So here the arithmetic mean for this data values is, that is arithmetic mean of combined series or group, is defined by this, that is n1 x bar 1, n2 x bar 2, n3 x bar 3 added together divided by the total number of observations. So this formula can be extended to any number of arithmetic means and observation, not just 4 values. Okay, so plugging in the respective sold quantities and their contribution or prices, the average arithmetic mean value would be this. Okay, so next problem is the service time, say in minutes, at airport ticket counter is given here. So then the median of the data is, okay. So here for finding the median, we have to arrange the data values in ascending order or descending order, whatever it is. Okay, so usually we are comfortable with arranging them in ascending order. We do that in ascending order. And in the arranged data set, median is, that is if midmost value you can say. Okay, that is if odd number of observations are there, then n plus 1 by second value would be the median. So here we have 11 observations and median would be 6th value. And looking at this 6th value, when you have 11 observations, so in competitive exams, if you want to save the time, here of course we have only 11 values. Arranging 11 values may not be that problematic, but time is also very important. So you can arrange just half of the values plus 1 values in the ascending order, because you are asked to find the median. You need not arrange the whole data set in ascending order. Start with the minimum value and end up at the n by 2 plus 1th value for arrangement, and then you can locate the median. The last item of that would be your median. So you need not spend your time in arranging all the data values in the order. Okay, so next is the mean of 10 numbers is 58. If one of the numbers is 40, okay, what is the mean of the other? So here what we do, it is average of 10 numbers. So average multiplied by 10 would give us the total values. And 1 is 40. So total is 580 less the 40. And now remaining values will be 9. So 540 divided by 9 would be mean of this remaining 9 values. Okay. So in a set of 30 numbers, the mean of 10 numbers is 15 and mean of remaining 20 numbers is 18. So the mean of 30 numbers. Again, the mean of 2 data sets you can treat. So n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2. Here x bar 1, x bar 2 are 15 and 30, N1, N2 are 10 and 20. So a simple calculation will get us the answer as 17. The next problem would be the mean of 9 items is 20. Okay. If one more item is added to the series, the mean becomes 21. The value of the newly added item. Okay. So here mean of 9 items is 20 means the sum of those 9 items would be 20 into 9, that is 180. And after adding one more, there would be 10 values. Mean is 21. So total will be 210. 210 divided by now 10. So you will get this. Or you subtract the first these values, that is sum of first 9 values. So the 10th item would be 30. Okay. And see, next is the median of 21 observations of a group is 40. We have 21 values and the median value of these 21 values is 40. Okay. If two observations with values 18 and 42 are further included to the data set. Okay. So now there are 21 observations, 2 are added to it. So there would be 23 observations or data values. And now median is 40. The two values that we are adding, one is 18, that is which is less than 40, and another one is greater than 40. So the middlemost values among the 23 remains the same. Okay. So the median of this new series will also be 40. Okay. By including one observation less than median and one value greater than median, middle value remains unchanged. So using this property, so median will be same. Okay. If the mode of the data is 15 and mean is 21, then median. Okay. We have a relationship between mean, median and mode, and that is this. Using this, median will be mode plus 2 mean divided by 3. Just plug in the values of mode and mean and you will get the answer. That is the formula. This is to be remembered. Okay. Next is the mean of 5 numbers is 23. If 5 is added to each number, then mean of this new series would be, that is when a same constant is added to every number, the average is raised by that number. So here 23 plus 5, 21, 28 would be the correct answer. So these are the certain things that one should remember, or properties. Directly we can answer the questions. Okay. So next is the mean of 5 numbers is 23. If 7 is multiplied to each number, okay, mean is. So when a constant is multiplied to each number, the average should also be multiplied. So 23 multiplied by 7 would be our answer. Okay. So next we shall come to standard deviation. That is a very highly used measure of dispersion in most of the statistics application. Standard deviation of 5 numbers is 6.7. Okay. If 6 is added to each number, standard deviation is. So there is a property, standard deviation is that is independent of change of origin. So when a number is added to every value of that series, standard deviation remains same. Okay. So our standard deviation of new series would also be 6.7. Next is standard deviation of 10 numbers is 6.7. 5 is multiplied to each number, then standard deviation. So when a standard deviation is multiplied by a constant, that constant multiplied by that if it is a positive constant. So our standard deviation for the new series, which is obtained by multiplying every value by 5, would be this, that is 6.7 into 5. Okay, that is the formula here is standard deviation of AX. A can be negative. So here absolute value of A, that is positive value of A multiplied by standard deviation of X. So again, one more example, a similar type. So standard deviation of 10 numbers is 6.7 and minus 5 is multiplied to every number, then standard deviation would be. So even if you are multiplying by minus 5, here the formula is absolute value of A. So the standard deviation is 5 multiplied by 6.7. Okay. So for two data sets, each of size 10, the variance are given to be 4 and 5. The corresponding means are 2 and 4. The variance of the combined data set is. So for the combined data set, the variance is formula is this, where here N1, N2, they are 10, S1, S2 are given. X bar 1, X bar 2 is also available in the example. X bar is not available, that is, it is the average of the combined mean. So just here, plug in the values, get the answer here. Okay. Suppose a population has 50 observations. The observations are 51, 52, 53, 100. Another population also has 50 observations, and those are this. Okay. So the ratio of the standard deviation of two populations is here this new series is obtained by adding 100 to the first series, that is corresponding values. Okay. So here the property is standard deviation is independent of change of origin. So standard deviation of both these would be same value. Okay. So the ratio will be 1. Okay. Explanation for that is given here. That is second series is obtained by adding 100 to corresponding numbers. So their standard deviation would be same. So the ratio will be 1. Okay. The mean and standard deviation of, see, these are first 20 natural numbers, 1, 2, 3, 4 up to 20 means first 20 natural numbers. Okay. So here these things we should know the formulas. The mean of first 10 natural numbers is n plus 1 by 2 and standard deviation of these numbers is this. So n is 20, plug in the values, get the answer. Okay. If average runs of player, so here we would be talking about consistency, that is coefficient of variation. We all know that coefficient of variation is a better measure compared to mean and standard deviation. The reason being that is for comparing two data sets, this is a better measure, and the formula for coefficient of variation is usually in books what we find is standard deviation divided by mean multiplied by 100. Okay. That 100 is just for our convenience or to make the value more presentable we do. But here when you are solving the example, you will be finding the CV for both the series. So for both of them, 100 is multiplied. So we need not think about that multiplication by 100. So just CV is standard deviation by mean. Calculate CV for both the data sets, and the one which has a smaller CV, that is more consistent. This is what we know from the theory. Okay. So the average person's monthly salary in a certain town jumped from 25,000 to 50,000 over the course of 10 years. Okay. What is the average yearly increase? So usually what we do in solving such examples, 50,000 minus 25,000 divided by 10 we would do. But that is not correct. Here, when there is growth rates and all, we should use geometric mean. Geometric mean of 25,000 and 50,000 is this. And this average increase in 10 years would be this divided by 10. Okay. So here you get the answer correct in this way. So per year on an average 3,535 would be the average increase, because at the end of first year what is raised, again that will be considered as the base for next year. So here geometric mean should be used, not this. Okay, that is difference of these two divided by 10, not. Okay, so we have now coming to probability. Okay, so this is some proper examples on central tendency and dispersion that have appeared in some of the competitive exams that I had considered so far. So now we shall concentrate on probability questions. Okay, so before start attempting the probability questions, some basic definitions. So experiment, we can say it is an operation which provides some well-defined outcomes. So experiment has got some well-defined outcomes, and any experiment is said to be a random experiment if we know all the possible outcomes. We can list all the possible outcomes, but at a particular trial, what would be the outcome? We do not know. Okay. The most common examples of random experiments are, that is we find in books. Okay. These are the random experiments. But we have, other than this, probability problems. So just don't think that that is rolling a die, drawing a card, coin flipping, picking up a colored ball from the differently colored, that is a box which has differently colored balls. These are the examples that we can quote to learn probability. It is not that, just to make the concept clear, these are considered. But very good examples of probability are there. Most probably I will be considering in the problems those examples rather than this. Okay. So event, outcomes that we get after performing an experiment are known as events. There are different types of events. Compound event, combination of two or more elementary events is called a compound event. And elementary event, all the possible outcomes after repeating a random experiment under exact conditions is known as elementary event. Next is mutually exclusive events. Events which cannot occur simultaneously are mutually exclusive. That is, in one particular trial, the events which cannot appear simultaneously are mutually exclusive. Favorable events, total desired outcomes of an elementary event are counted as favorable event. Independent events, if the outcome of one event is not affecting the outcome of other events, then the events are said to be independent. Here, usually students get confused with mutually exclusive and independent events. That is, if a question is asked, that is whether mutually exclusive events are independent or not. Okay, in some of the competitive exams, I have found this theoretical question also. Two events are mutually exclusive, whether they are independent. Okay, so here look at the definition of mutually exclusive event. That is, if one event occurs, the other cannot occur. Okay, so it means that happening of one event is hindering the happening of other event, so they are not independent. Okay, so mutually exclusive events are not independent events. So that is the question would be mutually exclusive implies independence of events. So here you have to think and answer. Okay, so probability formulas. The range for probability would be 0 and between 0 and 1, both inclusive. The addition rule is this. That is, this is verbally you can see probability of A or B. Okay, this, and probability of A and probability of its complement is 1. And if the events are disjoint, that is, they don't have anything in common, then the simultaneous occurrence of those two events will be 0. And if two events are independent, then simultaneous occurrence would be the probabilities of the product. And the conditional probability of A given B is probability of A intersection B divided by probability of B. And here the Bayes formula, this is very important in most of the application problems. Rather than this, Bayes formula is used. That is, probability of A given B is probability of B given A into probability of A divided by probability of B. Okay, now we shall consider some examples of probability theory, problems of probability theory that occur in competitive exams. And here, one thing I tell all those who are appearing for the examination, whenever you come across a problem or exercise on probability, first try to spend some 10-second extra on understanding the problem. This is very essential. Spend some additional 10 to 15 seconds in understanding the problem. And once you understand the problem, the result you will get very quickly. Okay, so first understand the problem. Whenever you are solving the problem on probability, so with all this experience, having taught for so many years and all, many a times suddenly when a probability example is given to us, instantaneously, we may not be able to solve it immediately. Okay, so please understand the problem properly first. Okay, so now see here, I have tried to avoid that rolling a dice, flipping a coin, card selection and all. Okay, so there is statistics or probability in other examples also which are more useful. Okay, a problem is given to 3 students whose chances of solving it are 1/2, 1/3 and 1/4 respectively. What is the probability that problem will be solved? Okay, the question is the problem will be solved means any one of them may solve it, 2 of them may solve it, or all of them may solve it. If any one of them, then A may solve it, or B may solve it, or C may solve it. If 2, then you have to see for the possible combinations of this and this, this and this, or one A and C, like that. So in such case, it is easy to find the problem is not solved. Okay. So 1 minus the problem is not solved would be our required probability. Okay. So here problem is not solved means A has not solved, B has not solved, and C has not solved. So here it can be simplified this way. Let ABC be the respective events of solving the problems. Then ABC are independent events. Unless they are copying the problem being solved, it is independent. Okay. So probability of A is 1 by 2, probability of B is 1 by 3, and C. So probability of none of them solve the problem, that is probability of not A and not B and not C. This and clause is important. So when you have a and clause, the probabilities are multiplied. When you have a or clause, the probabilities are added. Okay, so keep this in mind. And this is just the way in which we have to practice the solving of examples. Okay, so not A means 1 minus 1 by 2, not B means 1 minus 1 by 3, not C is this, and the problem is not solved, probability is this. So problem is solved is 1 minus this 1 by 4, that is 3 by 4. Okay. So next example would be tickets numbered 1 to 20 are mixed up, and then a ticket is drawn at random. What is the probability that the ticket drawn has a number which is a multiple of 3 or 5? Okay. So which is a multiple of 3 or 5. So now our sample space 1 to 20. Okay. Our favorable event space, all those numbers which are multiples of 3 and 5. First, write the multiples of 3 between 1 and 20, and then write the multiple of 5, and if they have already occurred, don't repeat again. So in this way, right, and count the number of elements here. This divided by 20 would be our answer. Okay. So next is a bag contains 6 white, 4 black balls. Okay. 2 balls are to be drawn at random. Find the probability that they are of same color. So here usually we use combinations. Okay. NC4 or NC2, NC3, like that. So instead of that, a easy way of solving this kind of problem is, because sample is very small. Okay. So total balls are 10 and 2 balls are drawn. They have not mentioned with replacement. So first, to draw first ball, you have 10 options. Anyone you can draw out of 10. And for second, you have 9 options. So a combination would be 90 ways. Okay. So both should be of same color. It means both should be either white or both should be black. Okay. So 2 white balls can be drawn in 6 into 5 ways. 2 black balls can be drawn in 4 into 3 ways. So as both of them should be white or both of them should be black. So we have a plus here. And they are disjoint events. So no intersection part. So you add the probabilities. So your answer will be this. Okay. So next question is, a man and his wife appear in an interview for 2 vacancies in the same post. Okay. The designation is same, 2 vacancies, and a man and his wife are appearing for the same post. Okay, the probability of husband's selection is 1 by 7 and the probability of wife's selection is 1 by 5. There is no gender discrimination as such I am making here. Just I have just coined the probabilities. Okay, what is the probability that only one of them is selected? Only one means either man will be selected or wife will be selected. Okay, so here if husband is selected, wife is not selected, or if wife is selected, husband is not selected. This way we have to think. Okay, say the event A is husband selected, event B is wife selected, and A and B are independent, and probability of A is 1 by 7. Probability of A complement, husband not selected, that is 1 minus 1 by 7, that will be 6 by 7. So probability of B is 1 by 5 and its complement is 4 by 5. So the required probability that only one of them is selected means A has occurred, not B. B has occurred, not A. Because only one of them is to be selected. So A and not B. This B and not A would be this. Add them and get the answer. Okay. So next problem is 3 unbiased coins are tossed. What is the probability of getting at most 2 heads? Okay. So here first write all possibilities, then at most 2 heads. So usually here at most and at least 2 words we should keep in mind. At least means from that number onwards, at most means from minimum to that number. Okay, so 0, 1, 2 possibilities, number of heads, at most 2 means. So favorable events for this among this will be these, and these are 7 out of 8. So required probability is 7 by 8. Okay. What is the probability of getting a sum 9 from 2 throws of a die? Okay. So there would be 36 possibilities, and getting a sum of 9 will be with these events it is possible. So the required probability is 1 by 9. Okay, a simple example, count example. Now this is interesting example. Actually it has to be solved using the Bayes rule, but here I have solved it in different way. Okay, just look at this. In my town, it's rainy 1/3 of the days. So probability of a day being rainy is 1 by 3. Given that it is rainy, there will be heavy traffic with probability 1 by 2. Given that it is not rainy, okay, a day may be either rainy or not rainy, and then it is rainy with this probability of heavy traffic. It is not rainy with there will be a heavy traffic with probability 1 by 4. If it's rainy and there is heavy traffic, I arrive late for work with probability 1 by 2. Okay. On the other hand, the probability of being late is reduced to 1 by 8. Okay. If it is not rainy and there is no heavy traffic. So when there is no rain, no heavy traffic, then the probability of being late to the office will be 1 by 8. Okay, in other situations other than explained here, rainy and no traffic, not rainy and traffic, the probabilities being late is 0.25. That is 1/4. So you pick a random day and then for that random day, answer these questions. Okay. So in that is competitive exam where exclusively statistics paper or questions on statistics are there you will get the example, that is the data, like in English comprehensive language and all, a paragraph is given and then 3 to 4 questions on that will be asked. Similarly, big information is given and 3 questions on this is asked. Okay, so you pick a random day. What is the probability that it's not raining and there is heavy traffic and I am not late? What is the probability that I am late? And given that I arrived late at work, what is the probability that it rained that day? Okay, so one way out to analyze what all information given, complete picture of what information given, is to have a probability tree. And once you plot that tree or draw that tree, the answer to all these questions will be very immediate. That is, maybe in 30 seconds you would be able to answer these 3 questions if you do that. Or another way is independently solve this. Okay, so rather than that, I feel it is better to have a tree diagram in this way. Let R be the event that it's rainy, T be the event that there is heavy traffic, and when you are attempting the question, you need not write these things. It is rainy, you will be knowing what do you mean by R, what do you mean by T, and what do you mean by L. Okay, so L be the event that I am late for work. As it is seen from the problem statement, we are given conditional probabilities in a chain format. Thus, it is useful to draw a tree diagram. Following figure shows a tree diagram for this problem. Okay, see, 1/3 of the days are rainy, so that probability is 1/3, and not rainy probability is 2/3. And if it is rainy, heavy traffic with probability 1/2. So 1/3 rainy and heavy traffic will be this, and rainy and no heavy traffic this. And here rainy, heavy traffic, late to the office, rainy, heavy traffic, not late to the office. Write down the respective probabilities here itself. So whichever part is asked, you will be able to answer. So probability of RTL would be product of this. That is rainy, heavy traffic and late. Rainy, heavy traffic, not late. Not rainy, rainy, not heavy traffic, late. Rainy, not heavy traffic, not late. So you can write the respective product to get this. It is very easy. Okay. Now the question is, first, what is the probability that it's not raining, there is heavy traffic, and I am not late? Okay. So it is not raining means this stream. Okay. And heavy traffic, and I am not late. So not raining, heavy traffic, and I am not late. Okay, this and this. So answer is 1/8. This way you can proceed. What is the probability that I am late? I am late means irrespective of whether it is raining, whether it is heavy traffic or not. Okay, so add all the late, what is that? I am late. Okay, all the late probabilities. So this 4 values you will get. Okay, so see, add all the 4 probabilities. And the last is, given that I arrived late at work, what is the probability that it rained that day? Okay, so given that I arrived late, given, so it is condition, what is the probability that it rained? So conditional probability R intersection L divided by P of L. P of L in answer B we have obtained it, and note that usually when for one information, when there are 3 to 4 questions, for later questions the answers of previous steps would be helping us to get the next answers. So this will be R intersection L. Okay, so this we will have. So this way it is very easy. Okay, so next question is, in a factory there are 100 units of a certain product, 5 of which are defective. Okay, we pick 3 units from the 100 units at random. What is the probability that none of them are defective? Okay, so let us define AI as the event that the ith chosen unit is not defective. Okay, so none of the units are defective, means first unit is not defective and second unit is not defective and third. So a clause of AND is there. So probability of A1 out of 100, 5 are defective. So 95 are good, 95 by 100. For the next one, because one good unit is already chosen, so you will have 94 good units and you will have 99. Okay, and the third one is 2 already good units are selected, third one also good, so 93 good units and denominator 98, and product of these 3 will be our answer. Okay, so next question is, a financial advisor believes that probability that the stock market will go down is 0.8, given that the economy deteriorates. Okay, the advisor also believes that the probability that the economy will deteriorate is 0.5. What is the probability that the economy will deteriorate and stock market will go down? Okay, so let E be the event, the economy will deteriorate, and let S be the event that the stock market will go down. We are given S given E. Okay, that is, believes that probability that the stock market will go down is 0.8 given that economy deteriorates. So this is given and probability of E is given, and we are asked to find the intersection, that is economy will deteriorate and stock market will go down. So this, and we know S given E, probability of S given E is this. This is given S given E and this is given. Okay, so the product of these 2 will be required probability. So we have obtained that. So now we shall move to some problems on probability distributions. Okay, so consider, mainly I am concentrating on the heavily used probability distributions, that is binomial, Poisson and normal distributions, and maybe if time permits couple of questions on exponential and maybe some other distributions. Okay, we shall see. It depends on the organizers, how much time they have. Okay, so probability distributions. Consider first we shall be discussing about binomial. consider the following scenarios: the number of heads or tails in a sequence of coin that flips, vote counts for two different candidates in an election, the number of male or female employees in a company, the number of accounts that are in compliance or not in compliance with accounting procedure, the number of successful sales calls, the number of defective products in production run, the number of days in a month your company's computer network experiences a problem. Okay, so in all these situations, we use binomial distribution. This is example. Okay, the framework of binomial distribution, there is a set of assumptions. For any statistical tool, the tool has several assumptions. Okay, our application of the tool would be successful only if we test for those conditions, okay, or assumptions. A set of n experiments or trials are conducted. Each trial could result in either a success or failure. The probability P of success is same for all the trials. The outcome of different trials are independent. Okay, so these are the requirements when to use binomial distribution. We are interested in the total number of successes in these n trials. And binomial probability law is given by this, for which mean is n into p, standard deviation is square root of npq. Okay, so now we shall start solving some problems using binomial distribution. An airline knows that 5% of the people making reservations on a certain flight will not turn up. Okay, those who have made reservation and they will not turn up, so that count is 5%. Okay, consequently, so because of this, they issue some extra tickets. Their policy is to sell 52 tickets for a flight that can hold 50 passengers. Means this becomes 4%. Okay, their experience is 5% people may not turn up, so they are issuing 4% more tickets. Okay, what is the probability that there will be a seat for every passenger who turns up? Okay, so what will be the probability that there will be a seat for every passenger who turns up? So probability that a passenger will not turn up is 5%, means 0.05. Okay, so a passenger turns up with probability 0.95. Okay, so x is equals to number of passengers who will not turn up. So x is a binomial will have binomial distribution with p this, and x can be up to 1 to 52 theoretically, but for this example, a seat is assured to every passenger who turns up if the number of passengers who will not turn up is more than or equal to 2. Because they are issuing 52 tickets, so the capacity of the flight is 50. Okay, so the number of passengers who remain absent is more than or equal to 2 would be the answer for this. Okay, so probability that x is greater than or equals to 2. So this is 1 minus probability x is less than 2, and less than 2, strictly less than 2. So this is x equal to 0 and x equal to 1. And using the this binomial distribution with n as 52, we have substitute x as 0 and here x as 1. So 50, any number, these things you should know while answering the questions. So NC0 is 1, NC1 is N. Okay. So directly substitute 1 into this and this. So any number raised to the power 0 is 1. So these two are 1. So we will be left with this. And 52 C1 is 52. And this. On simplifying, you get this. Okay. Probability that a seat is available for every passenger is this. Okay. So next example is the probability of a shooter hitting the target is 1 by 3. How many times he should shoot so that the probability of hitting the target at least once is greater than 3 by 4. Okay, so P is probability of hitting the target, that is given as 1 by 3. Probability of not hitting the target is 2 by 3. Okay. X is number of times the shooter hits the target. We have to find N so that probability of X greater than 1, greater than or equals to 1. That is how many times he should shoot so that hitting the target at least once. At least once means greater than or equals to 1 is 3 by 4. Or 1 minus this probability of X greater than or equals to 1 is 1 minus probability of X less than 1. Okay, this is greater than 3 by 4. So normally what mistake we do is when we take 1 minus this side also 1 minus is taken. But 1 minus, we are taking 1 minus of complementary of this. Okay, so that keep in mind. That is, in hurry we do such mistakes. So this is X less than 1 means X equal to 0. X cannot be negative. So 1 minus this is 3 by 4. And probability of X equal to 0 is this. Okay, Q value you know 2 by 3. So solve for N. And here don't immediately that how to solve this, it is polynomial, that this, don't worry. Go on for different values of N. Start. Okay, that is by inspection. When N is 1, it is 0.67. When N is 2, 0.44. When N is 3.3. So this should be less than 1 by 4. Okay. So here we got it. So our N is 4. This is how we have to proceed for this example. Okay. So next example is a student decides to guess on a section of his test. Okay. He has not properly studied. So ABCD choices are there. Here 5 choices. He goes on guessing. Okay. So the section contains 50 multiple choice questions and each question has 5 possible answers. Find the expected number of correct responses. Among 50, what would be the expected number of correct answer? Even on guessing, he does. Okay. So N is 50. Out of 5 choices, only 1 will be correct. So probability of the choice being correct is 0.2. That is 1 by 5. And expected number of correct responses. That is N. Expected value means mean. Here binomial distribution. Mean of binomial distribution is NP. So 10 would be the answer. Okay. So next we shall be discussing on Ozone Probability Law. If in the question it is not given which distribution to use, then how to decide whether to use Poisson or whether to use binomial would be a question. Okay. So for Poisson probability law, the probability of the event will be very, very small, and the number of total opportunities, that is n, will be very large. So even if they do not mention the following or underlying distribution, if these two are satisfied, or if one of the two is satisfied, then you can use Poisson probability law. Okay. So the Poisson distribution is another family of distributions that arises in a great number of business situations. It is usually applicable in situations where random events occur at a certain rate over a period of time. Consider the following scenarios. The hourly number of customers arriving at a bank, the daily number of accidents on a particular stretch of a highway. Compared to number of vehicles moving, the number of accidents is very, very small. So here it is modeled by probability Poisson. Hourly number of accesses to a particular web server, a daily number of emergency calls in some city or some agency, the monthly number of employees who had an absence in a large company. When in a company where there are lakhs together employees are there, so those who remain absent, that count will be very small. And there are many more examples, that is the how many policies will turn up for claim after meeting the eventuality out of the total policies sold, all and even the spray of insecticide. All these examples are usually we quote for that suit Poisson probability model. Okay. So the framework means the assumptions are, that is here again same, the very small probability and very big n, right? The distribution of number of events in an interval is same for all intervals of the same size. For a small time interval, the probability of observing an event is proportional to the length of the interval, and the proportionality constant corresponds to the rate at which events occur, that is lambda t, and the probability of observing two or more events in an interval approaches zero. Means however, when you consider a small interval, the probability of more than one occurrence is zero. This is a very important that is set up or framework restriction for the Poisson probability law. So this is the mean is mu here, and variance of the distribution is also mu. And if you are considering the experiment in t units of time, then mean would be lambda into t, that is the parameter and the interval length. Okay. So some examples: the number of accidents in a year to taxi drivers in a city has Poisson distribution with mean 3. Out of 1,000 taxi drivers, find approximately the number of drivers with no accident in a year. Okay. So here X is number of taxi drivers that meet with accident. If we assume, then Px is modeled by Poisson. Probability of no accidents means probability of X equal to 0. So m to the power 0, 0 factorial is 1. So you will have e to the power minus m, e to the power minus 3. You will get this as the probability of no accident. And out of 1,000 multiplied by the probability, and number of drivers with no accident would be 50. Okay. So next question is, if the probability of a bad reaction from a certain injection is 0.001, determine the chance that out of 2000 individuals, more than 2 will get bad reaction. Okay, so as the probability of incident is very low, here no underlying distribution is given, but we can use probability because Poisson probability law, because this probability is very small and this is very large, so we can use it. So, and here 2000 into 0.001, that is the injection being bad reactive. Okay, so our m would be this. Okay, so probability that x is greater than 2 is asked. So you can write 1 minus probability that x is less than or equals to 2. So this is 1 minus x equal to 0 plus x equal to 1 plus x equal to 2. So this will be the, if you write this and you get the answer this way, that is just plugging in the value of m as this, what we are getting as 2000 into 0.001. Okay, so next we will be discussing about normal distribution. The normal distribution is the most important distribution in statistics since it arises naturally in numerous applications. The key reason is that large sums of small random variables often turn out to be normally distributed. Price movement of a stock over a given period can be thought of as the sum of a long sequence of small movements. Hence, price movement is modeled by normal distribution. This is just an example. Most of the economic, finance, and even health science, insurance, all those examples, we have the use of normal probability law. Okay. Even in computer science also, that is reboot time, debugging time, they are all modeled by normal probability law. Debugging means there will be several errors in any program. So one by one we go on rectifying the bugs. So there also that is and normal probability is used in total debugging time and all. Okay, here I have considered an example of assembly time. Okay, the assembly time means construction time of computer can be thought of as the sum of times needed to build many individual components. We know a computer system will have so many sub-assemblies, and so the assembly time or build time is modeled by normal distribution. Okay, so the PDF of normal distribution is this. For when it is of this form, mean is 1, standard deviation, mean is mu, standard deviation is sigma. Okay, standard practice is to convert. Usually what we do, standardization means subtract by mean and divide by standard deviation, so that ready reckoner tables can be used to find several probabilities. So it is the standard practice. Okay, we have a question here. Suppose the return of an investment in a stock over a given time period is normally distributed with mean 10 and standard deviation of 5%. What is the probability of losing money over the given period? Okay, so here the return of an investment is mean 10 and standard deviation. So here we would be interested in knowing the probability that x is less than or equals to 0. Okay, that is losing means the loss. Okay, so here we have probability of x is less than or equals to 0 means where x follows normal with mean 10 and standard deviation 5. So standardize it. Probability of x minus 10 by 5 and right hand side 0 minus 10 by 5. These two will be equivalent events now. So this is standard normal distribution, denote it by Z. This is -2. Use the tables, get the values. Okay. So next, the marks of 1000 students in an examination follows normal distribution with mean 70 and standard deviation 5. Find the number of students whose marks will be less than 65 and more than 75 and between 65 and 75. So X represent marks, standardize it, X minus 70 by 5 and X equals to 60. When X is 65, Z is -1. Okay. So less than -1, that is the event that marks is less than 65 is same as the event that standard normal variable is less than -1. So referring the table, you get this value, and the number of students scoring, because this value is obtained as, would be, in all there are 1000 students, so probability multiplied by the total number is equals to this. So number of students scoring less than 65 is this. Similarly, when mark scored is 75, our standard normal variable would be Z equals to 1. So proportion of students scoring more than 75, that event is same as standard normal variable being greater than 1. And using the probabilities, you need not find it again, refer the table. This probability is same as this, so same answer. So the number of students scoring more than 75 would also be same. And the question is number of students scoring between 65 and 75, second bit. Okay, so we have obtained students scoring less than 65, scoring more than. So 1000 minus these two together would give us the number of students scoring between this. Okay. Next example is the probability that property will not be damaged by fire in a period of 1 year is 0.9. Okay. The probability density function of positive loss is given by this. Find the expected loss. Okay. So slowly from probability to expectation, this question. Okay. So here damage to the property is a random variable which takes value 0 with probability 0.9, because the probability that a property will not be damaged in that year is 0.9. Okay. So damage, if you take damage as the random variable, that value takes 0 with probability 0.9, and it takes positive value with this. That is, the damage would be this with probability 0.1. Okay. So the expected loss is the value taken by the random variable multiplied by the probability. So loss X takes the value 0 with probability 0.9. It takes this value with probability 0.1. Okay. So here expected value of X would be the PDF, that is, it will be some value with this into 0.1. Okay. I think I should have added X here. Okay. So here, right? It should be, otherwise it will become 1. So a typo, you can say this should be. Okay. This should be the situation. So you solve the integral, you will get the answer. Okay. So this is 5000 units. So expected loss would be 5000 units. Okay. So I ask the organizers, if I have time, I will proceed. Here I have considered some examples of insurance, utility function and all. Otherwise, we can
Yes,
stop.
yes, ma'am. You take another 10 minutes, ma'am.
Okay, okay. Suppose a decision maker has two random economic prospects. Okay. The possibility or likelihood of some future event occurring available. Okay. So he has two random economic prospects, and the outcome of first prospect denoted by X has normal distribution with mean 10 and variance 2. The outcome of second prospect, which we call as Y, it has normal with mean 12 and variance 6. See, this kind of examples, these occur in insurance, banking, probationary officers, and RBI that is examinations and all. Slightly advanced examples. These 2 to 3 examples I think I have considered here. Okay. Find which prospect is better. Okay. So applying the expected value principle to utility functions. Here it is, utility function is given in this way. And I hope wealth and its utility, if W is the wealth, its utility is. So it is exponential utility. And usually in theory, utility function is concave function. Okay. So any concave function for which this support is 0 to infinity, non-decreasing concave function is considered as utility function. Okay. So this anyway, whether we do not know or do not know the utility function or utility theory, we shall not bother. What they have given is utility function is given. We have to find its expected value, and the expected value for which prospect it is more, that is the better option, we can say that. So now expectation of u of x. So this is u is this. Okay. So minus e to the power minus 2x. So expectation of this is minus, I have taken outside, e to the power minus 2x minus as it is. This is nothing but moment generating expectation, MGF of normal distribution at t equals to minus 2. Okay. So this, and MGF of normal distribution is this. So substitute t as minus 2 in this, mu as say 10, and standard deviation, what they have given, it is 2 for the x prospect. So it would be e to the power minus 16. Similarly, find expectation of the second utility function. So whatever, same way, using the form of moment generating function, you get. Hence, see, we have, this is the expected utility for prospect X, this is for prospect Y, and this is preferred. Okay. So because expectation of utility of X is greater. Okay. So next example is, a decision maker has a wealth of W 100 units, and he faces the random loss with exponential distribution having a mean of 0.2. What is the maximum amount that he has to pay for complete coverage of loss if his utility function is given by this? So the wealth of the decision maker is 100. Utility function is this, and he wants the complete coverage of loss. So if at all he has to lose, he has to completely 100 units. So maximum loss would be 100 units, and what he is ready to pay to cover the risk of 100 units. So you can call it as premium amount, whatever it is. So here in these examples, the indifference utility philosophy is used. Okay, so just let me explain a bit detail. Here W is the his wealth. Okay, if he purchases the policy or insurance to cover or to safeguard these units, then he will be paying some amount. In that case, his utility or his wealth would be, because when he pays some amount to cover the risk of losing this 1000 units, then after that payment, his wealth will be W minus G. Okay. And suppose if he do not take the cover, means policy or insurance, then if he loses X amounts in this some accident or whatever it is, then his wealth would be W minus X. This is the utility function if he do not takes the cover to face the risk, and this is if he takes. And in both the cases, the utility is indifferent. Okay, for large companies, paying some amount will not change its wealth, and losing some amount will not also change. This is the principle of indifference in many finance and economics. This is used, and commerce people may be knowing better than we statistics people. So as far as possible, I'm trying to explain it. That is how statistics is used in such cases. Here the role of statistician is X is a random variable, and we have to find this expected value of the RHS. Okay, so this is utility function. In place of W, replace it by W minus G, and right hand side, in place of W, replace it by W minus X, and X is a random variable, so it's expected value. So simplification, expected value of X we should know, and that because X follows what is exponential distribution. So using that, you will get this as, and this is solving these two, you get the equation, a quadratic equation in G, and one of the answer will be negative for this, and G is amount that the person is paying to pay the risk cover, to get the risk cover. So negative value cannot be used here. So that is, so amount of premium paid is 0.2 units for every single unit. Okay. So one more example. An insurance company has a wealth of 5 crores. This insured means policyholder's perspective, we considered this example. Here company perspective. Okay. 5 crores and faces a random loss X with chi-square distribution having a mean of 50 units. What is the minimum acceptable amount this company will charge for complete insurance against random loss if its utility function is given by this? It is again exponential utility function, minus e to the power minus AW is the exponential utility function. And again, utility functions are non-decreasing, that is increasing concave functions usually. So irrespective of all that theory, W is wealth of insurer, H is acceptable premium, that is it gets from the policy holder. Okay, and the random loss is X. So if the company do not issues the insurance policy, his wealth is W. If it insures or issues the policy holder will give him H units of amount. So its wealth becomes W plus H. If there is a loss of X units, then its wealth becomes W plus H minus X. So balanced utility or indifference utility means what the utility was before issuing the policy and the same expected utility after issuing the policy and providing the benefit if there is a eventuality. That. Okay. So U is this, e to the power this. Okay. So W, right hand side, in place of W plus H minus X. So it becomes e to the power minus 0.0 W, e to the power minus 0.05 H, e to the power 0.05 X. So this and this gets cancelled. So left hand side you will have 1 and right hand side this is independent of X because it will be a fixed constant. Take it outside the expectation, you will have this, and here it is X is given that chi-square distribution with 50 degrees of freedom, that is N is given. So it is a moment generating function of chi-square random variable at t equals to 0.05. T means that usually we have the procedure of writing moment generating function as expectation of e to the power tx. So now that t is 0.05 we have. So this, and for chi-square distribution this is the MGL. So this expected value would be this. So 1 minus 2t, t is 0.05 means 1 minus 0.1, 0.9. So N is 50. Solve for H, and when you solve you will get H as. Okay, so this is to get a cover of 100 units. The company can accept 50 units as the premium. Okay, so I think last I will skip couple of examples here. One more last example let me consider. That is very simple. That is based on that is vital statistics. That is using survival function. Okay, because survival function is given by this when the support is this, and L0, that is it is 1 lakh. Find L1, L4, L6.5. So we know that L1 is number of individuals at age 1. L4 is number of individuals at age 4. And L6.5 is number of individuals at age 6.5. Okay. So L1 is L0 into S1. So L0 means there are 1 lakh people whose age is 0. That is, you can say newborn. L1 is out of this 1 lakh, how many will reach the age 1 year? Okay. So this is L0. And S1 is probability that they survive in the age interval 0 to 1. So here X is 1. It is given survival function. So 1 minus 1 by 100, that is 99,000. L4 is L0, that is individuals at age 0. Survival probability in the interval 0 to 4. And this is given here. So X is 4. 4 square is 16. So it will be. Means out of 1 lakh people, 84,000 people will reach the age 4. Similarly, out of 1 lakh people, these many people will reach the age 6.5. So usually that is here, one thing let me make it clear. It is X is 0 to 10. but human lifespan is usually considered as 0 to 100. So this example is suitable for any, say, birds population, or if it is a company which produces same type of units in large quantity. Okay, so it may be chips of some computers, or some, say, very that is spare parts, wherein huge production is there. Then how many will survive out of one production lot for 1 year? How many will survive out of this production lot, age 4 units, like that? And based on these probabilities, these values may help them to fix the guarantee or warranty of the components, things like that. Okay, I think I should stop here. Okay, some more examples are there, but similar kind. Let me stop here. Okay, now over to you, the organizers, please.
Hello, sir.
Hello.
Can you
Yes.
hear me?
Yeah, we are.
Thank you, ma'am. Thank you for such a brief explanation of the concepts in a very simple way. Thank you so much. The webinar was really very informative, and I hope that all the participants have taken the best use of it. Sir,
Now I
hello.
request Professor Rasmi Kokotnur Madam to vote of text.
Yes. Showing gratitude is one of the simplest yet the most powerful things one can do for each other. Hence, let me express my deepest gratitude to all those who were there in this webinar. To the foremost, I, on the behalf of the organizers, express my intense gratitude to today's resource person, Dr. B.Munoli ma'am, an eminent person who explained this practical problem so easily and effectively. Thank you, ma'am, for such an empirical and informative session. Thank you for your
It is my
contribution to this
pleasure.
webinar.
It is my pleasure. Okay.
Thank you. Thank you so much, ma'am.
And nice
Now,
meeting you all.
I am
Because among your staff, I knew only Prakash. So now I get to
okay.
know all of you. It was a pleasure. Okay.
Yes, sir. It was very nice, sir. I was, madam, I was also continuously listening to your tricks, that how we have to understand the concepts and all, because especially the students who are not in the stream of who are weak in maths or statistics basically feel difficulty in solving those tricky concepts. They don't understand the questions easily. So you explained it very easily, that how to grasp the concepts and how to answer it easily. Thank you, ma'am. Thank you for this such a wonderful moment. Thank you. Now, I, on behalf of the organizers, express my respectful gratitude to the principal of STC College, Dr. Jia Junaikar sir, for his persistent support and encouragement. Thank you, sir. Thank you for you also. Now, I also express my intense gratitude on the behalf of the organizers to the IQAC coordinator, Dr. M.N. Bennu sir, and sub-coordinator, Professor Y.B. Kodur sir, for their constant guidance and opinion for conducting such webinar. Thank you, both of you, sir, for helping us to conduct such a good webinar. Now, I, on the behalf of the organizers, express my thanks to the media person and also the Faculty of Commerce Department of STC College, Professor Vishwaj Kardev sir, who has been always supportive to us. Being a press reporter, he is always friendly to us, always been encouraging us to conduct such programs. Thank you for you also, sir. Special thanks to all the media persons who are helping us to know us. Now, I heartily congratulate and express the gratitude to the organizing secretary, Dr. P.R. Kengnar sir, and organizing coordinator, Professor Geeta Sajan ma'am, for conducting such a revealing and heuristic webinar. Thank you, both of you, sir and madam, for such a constructing gathering. Thank you to you also, sir and
Thank
madam.
you, ma'am.
Now, I heartily express my gratitude to all the teaching, non-teaching, technical staffs who gave their level best support and coordination for making this webinar a successful one. Thank you to one and all to you. Thank you to all the staff members who have been part of this webinar, to all the faculty members, especially commerce and statistic department staff members also. Thank you to you all. Last but not the least, I express my gratitude to all the participants of this webinar who made it successful, without whom this webinar would not be a memorable gathering. Thank you to one and all. Thank you to all the participants to making this for making this webinar a grand success. Thank you, one and all.
Thank you, ma'am. Thank you, Rashmi, ma'am. Thank you, ma'am, for giving wonderful presentation. Uh, so we will end the session. Good, ma'am. Okay, ma'am. Thank you, ma'am. Thank you so much. So we'll end the session here. I will send the
Yes.
feedback form to all the participants. So please fill the feedback form so you will get the certificate. Thank you. Thank you, one and all.
Thank you.